guys take a look. 9.4 is graphing systems of inequalities. Okay, so 9.4 systems of inequalities. We're going to graph one inequality, and then we're going to graph a system of linear inequalities. All right. So again, I recommend, you don't have to, but I always like using different colors. So let's get some different colors out. And you're going to have to do this via my math lab, so I'm going to try to give you some time in class so that you can get a grip on this. And what we're trying to do, guys, is we're trying to make it look like y equals mx plus b. Okay, hopefully we remember y equals mx plus b. It hasn't been that long since we talked about graphing lines. Remember, the b value is your y-intercept, where it crosses the y-axis. And just a reminder, when you have an x and y-axis, I put a little hump down here, put a little hump in it, and that's your b value. So the up and down axis is where we start. That's your b value. Okay, so you put your pencil on the B, and then we'll need our M, which is our slope, which is our rise over run. So as I take a look at example 1, I've got x plus y is less than 7. Okay, so the first thing I want to do is I want to get y by itself, so I'm going to subtract this x over. Okay, somebody says it. That hopefully better. So I'm going to subtract that x over, and now I've got y is less than negative x plus 7. And now I'm ready to graph this thing. Okay, so I go to B. What's B? What do you guys got for B? Help me out. The faster we get through this, guys, is based on how you're answering. What's B? Yep. Not negative, but, yep, 7. And then your slope. What's your slope? It's your rise and run. Yep, negative 1. So think of that as a fraction. I'm going to do negative 1 over 1. Okay, so we count up. So we put our pencil on the B. 1, 2, 3, 4, 5, 6, 7. So we put our pencil on the B. It's not hard, as you see. Man, we're having fun. Now it's time for rise over run, and then we go, we will graph you. We will graph you. So I put my pencil on the B, then we do our rise over run. We go down 1 over 1. Down 1 over 1. Man, this is fun. Down 1 over 1. That is your graph of your line. Okay, so now there's some rules that we got to know. Okay, if I have a less than or greater than, so it's less than or greater than, so not equal to, those are dotted lines. Dotted, dashed, not inclusive. Okay, versus if I have less than or equal to, greater than or equal to, if I have that little bar on the bottom, that means normally we do a bracket on like a number line. Well, those are going to be solid. So less than or greater than is a dotted line. And then less than or equal to, greater than equal to. And then we'll go ahead and use our little My Math Lab tool. Draw a line. It's pretty easy to do. And the last thing we got to do is we need to do our shading. We got to know which way to shade. Okay? So I'll go ahead and write this over here. If it's greater than, or greater than or equal to, I shade above. So if I'm greater than you, or if I'm greater than or equal to you, I'm above you. And if I'm less than you, or less than or equal to, I am below you for the shading. Okay, so when I do my shading, I take a look and I say less than. Okay, so what I'll do is I'll find the y-axis here. Okay, and then I have to decide, do I shade above the y-axis, above this line, or below this line? Okay, when I teach my freshmen, I tell my freshmen this is like a totem pole, the y-axis. Do you guys know what a totem pole is? Like in Indian culture, there's like a totem pole. It's like a big wooden pole. It's like a tree, right? It's a pole made out of wood, and they carve faces in it. Well, the higher you are on the totem pole, the more important you are. Right? So if I'm greater than you, I'm above you. I'm up the totem pole. If I'm below you, I'm down the totem pole. If I'm less than you. So again, this is less than, so I'm going to shade below the totem pole. Okay, so I'm shading down the y-axis. Now, another technique that you guys can do if you don't like the above and below idea, you could also choose like a coordinate point, let's say 0, 0, the origin, and you could plug that into your inequality. You could plug it into the original one or plug it into this one here. So if I'm testing, if I want to test, I could do 0, plug in 0 for 0, 0. I have 0 is less than negative 0, and then plus 7. Is 0 less than negative or positive 7? Is 0 less than 7? For sure, right? The alligator's eating 7 people versus no people. So that works. If you chose a different point, maybe this one up here at 10, 10, you would see that that didn't make sense. Okay? And you would shade in the opposite direction. All right. So final answer is right here, guys. Final answer. I graph it. It's dotted because it's not equal to, and it's less than, so I shade below. All right, you have seen this multiple times. This isn't the first time you've seen these graphs, so let's do another one. A little practice. All right. Next one I got is x is greater than or equal to 7. Do you guys remember? Is that what type of line? An x equals line. Yeah. Yeah, it's going to be solid. And then, do you guys remember the alphabet? U, V, W, X, Y, and Z. Remember that alphabet back in the day? When we did this, graphing these special lines. If I have an x equals line, right next to x is V, and V stands for vertical. So this is going to be a vertical line at 7. So I go to the x-axis and I count 1, 2, 3, 4, 5, 6, 7. And now Greg says this is a vertical line right here at 7. Shade up or down, that doesn't make sense. I have to shade left or right. So this is kind of like what we just did with the number line. If it's x is greater than 7, which way do I shade? Do I shade on the right-hand side or the left-hand side? If x is greater than 7, where are those numbers? What do you think? Destiny, Kai, Lily, which way do we shade if x is greater than or equal to 7? Maddie, Jasmine, what do you guys think? Left or right?
Right, because it's greater.
Yeah, Lily says to the right, greater than is to the right. So I'm going to shade all those guys. I'm like halfway done. Look at that. All right, next one. If I have y and just a number, that's on this side. So I have y and z. Z is horizontal. A zero slope. It's fun to say. So y. If I have y is less than negative 3, that's going to be a horizontal line at negative 3. So I count on the y-axis. 1, 2, 3. And I have to decide, is this a solid or dotted line, y'all? Solid or dotted? This is a dotted or dash, whatever you want to say. Jasmine says it's a dotted line. Awesome. And then less than. Do I shade above or below this line if it's less than? Above and below. If I'm less than you, am I above you or below you? below, so I'm going down. I'm going down. I'm yelling timber. You better move, you better dance. Hashtag Kesha. So now my answer, my final answer is where the blue and the, I guess, fuchsia make a bluish fuchsia-ish color, right? Like Mr. Gotch's hat. Bluish fuchsia color. What do you think? So the overlap is happening right here. So we're blue and purple together, or fuchsia, or whatever that color is. Okay, so final answer. So any coordinate point in this region works in both of these inequalities. Okay. If I pick a point up here, it just works for the x is greater than or equal to 7. If I pick a point over here, it only works for this one. I want to find out where it works for both of them. All right. How are we doing? Not too bad? All right, we got 2 more to do, guys. The rest of the time will be yours to work on homework. And some of us are getting behind on homework. We need to get some time here. All right, let's do it, huh? So let's do this one here. So here I've got x plus 2y is less than or equal to 8. Again, we want y equals mx plus b, right? So first thing I need to do, I want to get this 2y by itself. So I'm going to move this x. How do I move this x over? Subtract it over. All right, so I've got 2y is less than or equal to negative x plus 8. And now we want to get this y by itself. How do I get rid of 2 times y? How do I get rid of the 2? And divide it. Now, if you divide it, you got to divide everything by 2. So what I end up with now is y is less than or equal to negative 1/2 x. And 8 divided by 2 is 4. Bless you. That was a good one. All right, so again, negative x over 2 is the same thing as negative 1/2 x. Same idea. All right, what's b? B. Kai, Destiny, what do you guys have for b? Taylor, Ethan, Riley, Juliana, what is b? Shout it out. Use your chat, guys. What does the ceiling fan say? Jose, Jimmy, Isabel, what do you guys got? What's the b value? No, the b value. Y equals mx plus b. What's b? People at home, come on, let's go. Wake up. I'm asking you a question. What is the b value? Y equals mx plus b. Help me out. 4. Oh, man. It's unfortunate that I only have one person that can answer that. I'm a little worried. Well, one person at home that can answer that. So I put my pencil on the B. 1, 2, 3, 4. And I got M. I'm here negative 1/2, right? So it goes negative is going down and over to the right 2. Down 1, over 2. You can do that as many times as you want. Again, for my math lab, you just need to do it one time. Find your slope. And solid it out if it's less than or equal to. Shout it out. What do you guys got? Solid it out. Yeah, Maddie says solid. Excellent. Okay, so I've got a solid line there. This is an arrow. Sorry, and the arrow's very good. And then less than or equal to. Above or below? Do I go up or do I go down? Which way? Below. The other thing is less than has an L in it, below has an L in it. And less than sign looks like an L, even better. All right, perfect. All right, the last one I've got to graph is I got y is less than 3x. So if there is no b value, that's just 0, the origin. And then my slope is 3. Think 3 over 1 for your slope. So here's 0, right there at the origin where they meet, the x and y axis. And then we're going to go up 3. 1, 2, 3 over 1. 1, 1, 2, 3 over 1. You can also go down 1, 2, 3 and to the left. Down is negative and left is negative. And that way it stays a positive slope. Okay? Less than. Solid or dotted?
Dotted.
Yeah. Was that Kai? Attaboy Kai, if that was you. Fantastic. And then less than is what? Below? So find, I always find the totem pole. Here's the totem pole, and I shade down the totem pole. So it's all this. Okay, now it's where the overlap happens. Now, if you're just guessing, if you think about it, when two lines intersect, there's usually 1, 2, 3, 4 chances of you getting it right. 1 out of 4. So that's why we want to shade a little bit. There's always 4 getting it right if you guess. So don't guess. Do your shading, and then it makes it very clear where the purple and the blue match up. And the purple and the blue match up right here. Look at that. Good stuff? Questions? All right. I want to talk about this last one because there's something crazy that happens that I want to refresh your memory. All right, so when I take a look at this one, we'll do this one in blue. I've got x minus y is less than 2. So the first thing I would do is I would move that x over. So I'm going to use subtraction. Now I've got negative y is less than negative x plus 2. And I have one more thing I got to do. What do you have to do here? How do I get this negative out of here? Not add y. Good guess. This is like negative 1 times y. Not add it. This is like negative 1 times y. Yeah, I got to divide it. So I'm going to divide everything by a negative. Basically switch every sign. When I divide, this negative x over negative 1 is a positive x. 2 divided by negative 1 is negative 2. But anytime you divide by negative, you must switch or flip your inequality sign. That's just the rule. So let me make note of that. If you multiply by a negative, multiply or divide, flip it. So you got to flip your sign here. That is now greater than. Okay, so anytime you multiply or divide by negative, make sure you flip that sign. So we'll go ahead and graph that. So I go down to 2 for my b value is negative 2. So I go down 1, 2. And then my slope is 1, think 1 over 1. So that makes it easy. Up 1 over 1, up 1 over 1, up 1 over 1. And it's greater than. We got a dashed. And then it's greater than, so do I shade above or below? Yeah, greater than is above, so I find my totem pole and I shade above this guy here. So far, so good. All right, so the next one I'm going to take is this. X plus 2y is greater than negative 2. I'm going to subtract x. That is not multiplying or dividing, so I don't change the sign there. Just leave it as 2y is greater than negative x minus 2. So again, I subtracted the x, and now just divide by 2, divide by 2, divide by 2. And we end up with y is greater than negative x over 2. I like writing that as negative 1/2 x. And then negative 2 divided by 2 is negative 1. And that's what I'm going to graph. Okay, so I have a b value that's negative 1, and I have a slope that's negative 1/2. So I put my pencil on the b, negative 1, and then I do my slope. I go down 1 this time, over 1, 2. Down 1 over 2. Man, that's fun. Rise over run. And there we go. Go ahead and graph this guy. What is it? Solid or dotted? Greater than. Not equal to. Shout it out.
Dotted.
Yeah, dotted. Dotted, dashed. Let's pick the dotted tool when you graph these. And then greater than is finding the y-axis, and then I go up the y-axis. Okay? So again, when you look at it like an X, there's 4 sections, right? This one has nothing. This is blue. This is purple. Ah, right here. This one is perfect. This has blue and purple in it. So that's where my final answer. Any point in that section is going to work for both of those inequalities. Okay? So when you graph these guys, always put them in that slope-intercept form, y equals mx plus b. I think it makes it very easy to graph them. You usually only have to do 2 steps to get it into that form, usually a subtraction over and then a division. Just be careful anytime you multiply or divide by a negative, you got to flip both signs. Flip that inequality sign.